The next maneuver will be the flyby.
No, you can dog me as much as you want. Yeah, so I'm
5 past, starting now. Maneuver complete. Our next maneuver will be the horizontal figure 8. Figure 8 starting now. Is the wind coming out of the south more now?
It is.
Picking up left to right.
Okay. Maneuver complete. Our next maneuver will be a chandelle. Chandelle, starting now. Maneuver complete. Our next maneuver will be descending 360. Descending 360. Starting now. Maneuver complete. Our next maneuver will be a wing over. Wing over, starting now. Maneuver complete. The next maneuver will be a loop. Loop, starting now. Maneuver complete. Our next maneuver will be a stall ahead, biasing a little bit into the wind. Although there's not a lot right now.
Seems like a nice flyer.
Nice job.
Okay, stall ahead, starting now. Maneuver complete. We'll do a circuit first.
Okay. On the next.
Yes, this will be the landing.
Landing. Nice. So John, tell us about the full size that this was modeled after.
It's the Havilland DH-82A Tiger Moth. First flew in 1932 and is a great example of engineering on the fly because it's a development from the Havilland Moth, and the RAF was concerned because their egress from the front cockpit was tough, and so they wanted to make sure that the instructors could get out if they needed to. So they wanted to move the cabane and tank structure forward 18 inches. So they moved that forward 18 inches and then swept the wings to keep the CG in place. And they ended up with different dihedral and sweep for both wings, so there's nothing above the top and bottom wings that are the same. The one thing that you might notice is the ribs are still like the straight wing Moth, so they're not in line with the airflow. And so they just swept the wings back. And then when they were test flying it, they found that the lower wing was close to dragging the ailerons, so they cranked in more dihedral to the bottom wing. So it turns out that it works very well, but it was kind of engineer as you go. But it was an excellent train. It was used throughout the 30s and through the war for pretty much anybody that flew in the RAF in World War II did their primary training in the Tiger Moth. And after the war, it's been a very popular general aviation airplane in the UK. This color scheme is from an airplane in the 80s. It's still around, still registered as G-TIGA, but it's now in a green and yellow paint scheme.
Where's it based?
I'm not sure.
In the UK?
In the UK,
Oh, okay. Yeah. And then, John, tell us about the model.
Okay, the model is quarter scale, so it is pretty accurate to quarter scale. It's an 88-inch wingspan, weighs about 15 pounds. It was built from a Duncan Hudson kit with a fair amount of modification. I was worried about balancing it, so most of the structure behind the cockpits is balsa instead of spruce. But I was pleased that it came out without any ballast and weighs about 15 pounds. It's covered with SIG coverall and using the Stitz paint system. The engine is a Sato FG30. It's a 30cc gas-powered four-stroke. And I'm using a Spectrum radio. I fly NX10 transmitter, and all the receiver and servos are all Spectrum as well. There's 2 aileron servos and 1 servo each for the elevator and rudder. The rudder cables are scale and functional. The cables for the elevator are dummied up. I have a regular push rod, aero shaft push rod for the elevator control, and the cables just are wired into springs inside the fuselage because all of the cable details are reproduced, and I was a little bit nervous about making all those work properly. I fly it on 6-channel in addition to the 4 primary flight controls. I also have a ignition switch in it, so the radio setup is pretty straightforward. I tried to find, I originally was looking for a simpler prototype without the anti-spin strakes on the back and without the slats, but I like this color scheme enough that I went ahead and did it anyway.